Hello, good morning, sir. Anand, sir.
Good morning, sir.
Yeah, sir. Shall we start with the session, sir?
Yeah, sure.
Yeah, sir. 1 point.
Pleasant day to all of you. Pleasant day to all of you. Greetings to all on this wonderful afternoon. On behalf of all present, I extend a cordial welcome to each of you joining us on this splendid afternoon. As the sun bathes us in the golden light, casting a radiant glow over this gathering, I am filled with a sense of eagerness and expectancy for the experiences awaiting us. It gives me immense pleasure to greet Anand sir, today's resource person. He is an ML analyst currently working at Vismaya Infotech Solutions, Trivandrum. He completed his course in Electronics and Communication Engineering at National Engineering College and ME Communication Systems in MEPCO Skeleng Engineering College. He has experience in teaching for 10 years and 1 year in industry. His area of interest are signal processing, image processing, machine learning, computer vision, and data science. He handled many sessions and delivered workshops in signal processing, image processing, and Python programming. He published a book titled Data Science with Raspberry Pi, a localized cloud approach in July 2021. With immense respect and excitement, we are pleased to welcome Anand sir. His existence here today reminds us of the heights that can be attained by a lifetime of unflinching devotion to and love for one's occasion. Today's session is about optical character recognition (OCR). Participants try to be interactive to make this session a valuable one. It is with great pleasure that we greet you, sir. The session is yours.
Thank you so much for the wonderful introduction. So, am I audible to all the participants? Please give a hand raise if I'm audible to you.
Yes, sir.
Okay, thank you. So, let me share my screen. Is my screen visible? Is my screen visible to all of you?
Yes, sir.
All right. So before I begin, I would like to give a small introduction to my company. So we are working on cutting edge solutions for various sectors like banking, telecommunication, energy and utility, and other government services. So we are based on Qatar with a working branch in Trivandrum, and currently we are venturing into AI solutions as well. We are creating solutions for recommendation systems and smart city solutions, and many more are on the pipeline. So it's an immense pleasure for me to deliver this topic today, representing my organization as well. So today I'm going to talk about optical character recognition. Can anyone tell me, do you have an idea of what OCR is? Optical character recognition is. Anyone, please?
Participants kindly respond to them.
All right. Okay. So I'm sure some of you might be aware of this. So optical character recognition is the process of recognizing text in images of documents. So when we say documents, it is a digital document where we have a typed text which we can copy, edit, or do anything. But when we have images of documents, say a scanned copy of a document, or a photograph of a document, or consider a photograph of a name board in a shop. Okay, so you're going to a different location, a different state, where you're having a Hindi board, a board in Hindi, and you want to know what it is. So you can capture the image using your mobile camera, and this OCR, using this OCR technology, you can recognize that image. You can copy it, or you can translate the image, or you can do anything once we get the digital version of the text in the image. So this is the fundamental idea of OCR. So in this session, I intend to take you on a journey uh, to learn as well as appreciate how much OCR has developed over the years. So this is what I was explaining. What is an OCR? So we provide a document image which can be of any format. It can be a scanned document. It can be a photograph of a document. It can be a photograph of a QR code or barcode. Even barcode and QR code or characters. Okay. So once we uh, provide the document to the OCR system, it will return as an editable text. Okay. So if you are giving an image of a document, it will give an editable text where you can copy the text from the image. Or if you give a QR code, it will give you a URL corresponding to the QR code. Right. So this is the singular purpose of OCR. So it is, you can consider it as doing two things. One is text detection, detecting the text from the image, and the other one is recognizing the text. Let's go back in time. So when did this OCR gain traction? So initially in 1914, before World War One, Immanuel Goldberg, right? He was the first person who developed a machine that could read and recognize characters and convert it into a telegraph code. The telegraph codes, there are a number of codes that were used in those times. Even Morse code can be considered as a type of telegraph code. So his machine can read an image from a photograph. It's not exactly a photograph. It is called as a microfilm. At that time, they were using microfilm, similar to the film roll where we used to use in our analog cameras. So there were microfilms holding photographs of text documents. So he created a machine which he named it as a statistical machine that can search through these archives, microfilm archives, using an OCR system. Okay, but it was not a computer program at that time. It was a machine. It was based on a photoelectric effect. He did that. And later on, in 1974, the first breakthrough with respect to computer coding in the field of OCR. So this person, Ray Kurzweil, he established his own company and he's developed the first OCR system that was capable of recognizing all the printed fonts available at the time. Okay, it can recognize printed text in any font available at that time. So once he developed that machine, he wanted to use that to assist visually impaired people. So what he did is, in a couple of years' time, in 1976, he unveiled what is called Kurzweil reading machine that can capture these images, extract the text, and convert it into speech. And he started selling a commercial version of the OCR later on. As a software, he started selling a commercial version. So these were the uh, first initial well-known works that these guys pioneered in this field. And later on, after 1980s, with the computers and the memories and the storages, everything developing at a rapid rate, more and more system came into being, overcoming what they were doing. All right. OCR applications. So these are some of the applications. So in digitizing documents, so the foremost application when the OCR system was coming into picture was to digitize the text. So it could be used in banking and healthcare. You know, in banking, we are coming across numerous forms, right? Even now, banks, even though they have moved on to digital banking, still physical forms are being used to some extent. So banks can use this OCR applications to convert these forms into digital text. And healthcare, again, the patient records their previous reports, everything are in printed form. So the doctors can simply use the OCR system to store their patient details in a digitized format. And retail, like I said, the OCR, the QR codes that you are scanning to pay at the retail stores, or the barcode scanners they are using there, all these come under OCR. And as Kurzweil implemented, so we can develop a system that could assist the visually impaired by capturing the text, even when they are navigating in a busy street. So this system can detect the text from the boards around, and it can inform the person where they are, what is near them, right? Not just for reading purposes, it can be multi-purpose for visually impaired. And automatic number plate recognition. So most of you might be aware, some of the governments, state governments are implementing number plate recognition at traffic cameras. So no matter how fast you are traveling, these cameras are able to capture the number plate from a moving vehicle and effectively extract the plate number from the vehicle. So the automatic number plate recognition, this is being developed as a camera itself. So the OCR is built into the camera. It is developed as a standalone unit itself. There are a number of ANPR cameras available. And self-driving cars, pardon for the mistake there, it's not cars, it's cars. So autonomous cars, self-driving cars. So these cars, when they are moving in a road, so they need to be aware of the traffic signs available and maneuver accordingly. So again, OCR plays an important role in detecting these signs around the road. Now, traditional OCR pre-processing. Can someone please tell me what is meant by pre-processing? Anyone here with some knowledge on image processing? What do you think pre-processing is? Am I audible? Hello, am I audible?
Yes, sir.
Okay, thank you. All right. Pre-processing is the set of steps that we perform initially to prepare the image, to make the image ready for further processing. The captured image as it is sometimes does not produce good results. So we need to do some processing to enhance or to make the image suitable for further processing stages. Okay. So these are some, we are talking about traditional OCR systems here. Now we are into more advanced deep learning technologies that can perform this. But initially when we are implementing traditional OCRs, we have to perform certain pre-processing steps. So the first one is deskewing. Again, apologize for the mistake there. It's a deskewing. There's a typo. Deskewing, the image we captured, the text may not be in a straight line. The document may be slanted, or we may not be placing the camera in a better position. So in that case, we need to skew the image in such a way. It can be either rotation, or it can be, you know, a trapezoidal kind of movement we can do to get the text in straight lines so that the further processing can happen effectively. Next, we might end up with low contrast images depending on the location we are taking or depending on our devices. So in that cases, we might have to improve the image contrast to make the recognition better. And denoising. So often, again, due to the quality of the camera or due to other effects, there may be artifacts in the image, there may be some salt and pepper noise, there are some types of noise there. So we will have to remove the noise. So these noise can cause the text to be wrongly recognized. So we have to be very careful that we have to apply denoising to remove these artifacts. And then binarization. So almost always with respect to OCR, we will be working on black and white images, which is uh, better suited because we need to separate the foreground from the background. We need to separate the text from the background. So it is enough if we have two colors. So this is always the case. And then normalization, where if there is any variations in illumination across the image, one side is highly illuminated, one side is dark. So we can apply normalization to adjust the illuminations. So these are some of the pre-processing techniques. There are more you can explore that were originally used in traditional OCR. And for recognition, once after the pre-processing, two methods were commonly employed in traditional techniques. First one is a pattern recognition. So this technique compares the entire image with a predefined template. For example, you see the letters N and H here. So we will have template images for each character stored in a database. So we will take the entire image of N or H. We will compare with the templates of all the alphabets in the database. And when the template is matching, we will say that, okay, this letter is N, this letter is H. So it will focus on recognizing the entire pattern or shape. Whereas the second technique, feature analysis, it will try to identify distinctive features like orientation or curvature, stuff like that. For example, if you consider this same thing, if it is both N and H have two vertical lines, if the two vertical lines are connected by a slanting line, then we can call it as N. If the two vertical lines are connected by a horizontal line, then it is H. So feature analysis focuses on specific attributes, individual attributes, whether there is a straight line, whether there is a slanting line, whether there is a curvature, a sphere or hemisphere, okay, things like that. So based on that, it will try to detect the image. So these were the most common techniques that were traditionally used. Then machine learning gained popularity as soon as the computing capability started increasing. We could say that after 2000, the machine learning gained more popularity. Even before that, it was there, but more computation, we got more computation capabilities in the 21st century, once the 21st century started. So the difference between the conventional programming and the machine learning programming. So in conventional programming, we provide the data, which is the input, and rules, which is what we call as the program, the code. Once we feed the code with the data, it will produce a result. So I'm sure you have all done, you're all capable of coding, you're all done coding. So I'll go to a very, very basic example of what we have done during your college time. So we would have written C programs for computing sum of two numbers or greatest of two numbers. So all these things, you feed the input numbers, you write a set of rules, that is a code, it may be if condition or for loop or whatever, and it will produce a result. Whereas in machine learning, you provide a data and the result. So you provide the input and the desired output, and the algorithm tries to learn the relationship between the data and result. So this output should be rules. Again, I apologize. So the output will be a set of rules that relates the input to the output. All right. Any doubts in this? Can you understand this? So in machine learning, we provide the input data and the desired output to the code. The code learns the relationship iteratively between the input and output. So it develops the rules itself. So what are the rules to get this output from this input? So can you understand the difference between this conventional programming and machine learning? So I mean, this is very fundamental, but still I want to take it in a way that everyone gets to follow. So can you understand this? Can you give a hand raise if you can understand? All right. Thank you.
Sorry for the interruption, sir. There is a
Yes,
question in chat box. Can you answer for that, sir?
sure.
Okay, sir.
How to check the accuracy rate of OCR? Enhancing the quality of image or characters in the image. Okay. It is about enhancing the quality of images. Characters, as a next step, we have to extract from the image. So first, the image has to be in a better quality. So once we enhance the quality of the image, then automatically we can isolate the characters accordingly. So that's what I said. The pre-processing steps I mentioned here are just limited. There are more. So sometimes there may be artifacts connecting characters in between. Sometimes the characters will be broken. So there are techniques like morphological processing in image processing to address that. So character level processing is also available. So initially we will enhance the quality of the image. Then with respect to character, if you have to do anything, so those processing could also be done. And how to check the accuracy rate, I will come to that. So I will show you uh, a sample code, and we will discuss during that. All right. So machine learning again can be classified into traditional machine learning and uh, deep learning. So traditional machine learning, that word is not a single algorithm. It denotes a subset of algorithms, a number of algorithms that can be broadly classified into two categories. One is supervised learning and unsupervised learning. So I don't want to go into detail into the algorithms. So I'll just say what is supervised learning and unsupervised learning. Supervised learning is where you provide the uh, uh, algorithm with both input and the corresponding output. So for example, if you are going to train images, say, I'll give an example, a classification example. You have a set of images of cats and dogs, which is a very popular implementation in image processing. So cats and dogs. So for each image, you have the label, whether it is a cat or a dog. So you provide the images as well as the labels to the system. And based on the two, it will try to come up with uh, an algorithm or a solution to identify that this image is a cat or this image is a dog. All right. In unsupervised algorithm, we will not have labels. We will only have images. So, so how does that happen? Okay, in supervised learning algorithm, we give the input and output. So it has something to work on, right? But how does unsupervised algorithm works? So even if I provide uh, just the images, how does the system learn from that? So there are approaches like clustering. So where it tries to group similar images together or similar data together. So when I say traditional machine learning, it can be image, it can be text data, it can be anything. Okay, so the data can vary. So in unsupervised learning, it will try to group similar categories together so that it can finally classify which belongs to which category. Okay. So these are the broad categories, and there is something called a semi-supervised learning algorithm where you may not have labels available for all the data with you. So wherever label is available, you can provide, and when the label is not there, the system will adapt. So okay. So traditional machine learning algorithm laid the foundation for early systems. So now almost entirely we are using advanced deep learning based OCR systems. But traditional systems laid the foundation for this advanced systems. Okay. So again, the techniques they employed were like template matching. So like I said, when they cluster images together, so they check for templates. When they check for similarities in the image, okay, by default they check templates and they extract features that correspond to each images. So what are the features corresponding to a dog? Right? What are the features corresponding to a cat? Right? The cat may have a different pointy ears. The dogs may have some dogs may have pointy ears. Some dogs may have different kind of ears. So like that, it tries to learn features. And then statistical analysis. It can perform a range of statistical analysis to identify and recognize characters. So we are talking in terms of OCR here. So it can perform statistical analysis. One prominent technique that traditional machine learning technique that was used to build OCR was KNN, K nearest neighbor algorithm. Uh, there are systems available online. You can check on that, right? Simple to learn how this works. Then enter the picture the deep learning networks. So the neural network is the foundation for all the deep learning techniques. So this is the simple structure of a neural network. So here the individual circles are called nodes, whereas the lines connecting them, they indicate the flow of information. The nodes are categorized into layers. So the first two nodes comes under the input layer. The next set of three nodes, they are called hidden layer 1, hidden layer 2, and finally we have one output layer. Okay, so the nodes are grouped together into layers. What is the number of layers we need? So there is no fixed uh, procedure. So depending on the problem, depending on the type of data, so we may have to implement different types of different configurations to find out which really works out. All right. So what is this node? So these nodes, if you look at this general structure, these nodes can be thought of as neurons, like the neurons in our brain. So in our brain, when a neuron receives information, it will process that and send that information to other neurons around it. And they will further process it and send it to the other neurons. So this works in a similar way. These nodes can be thought of as neurons, and these like the arrow marks, the lines, they are like spreading the information to the other neurons. So that is why the neural network, we call it as artificial neural network. It's commonly called as artificial neural network because it resembles the functioning of a neuron. So what this node does, say for example, let this be input layer. So we have some n number of inputs, x1, x2, etc. up to n. And in the next layer, so you can see that in each layer, this is called a fully connected network. Every node in the previous layer to connect it to every other node in the next layer. For example, if we consider the first layer, it will be connected to all three. We consider the second node, it will be connected to all three. So such kind of connection, we call it as fully connected networks. Okay. So let this be input layer. Let this be a single node in the next layer. So what happens is when I pass the input to this layer, the input will be multiplied by the weights. These weights are called as the parameters of the model. This is what we will be tuning to learn the relationship between input and output. So x1 will be multiplied by a weight w1, x2 will be multiplied w2, it will go on, and xn will be multiplied with wn. And in this node, we will add every thing together. All the multiplication results, we will add them together. And then that result, we will pass on to something called as an activation function. This activation function can help to discover nonlinear relationships in the data. And finally, that this node will give an output, which will be passed to the next layer. The output can be treated as f of z, applying the activation function over the result z obtained by the sum of products. I hope you can follow this, right? It is simple multiplication and addition followed by a simple activation function. Any questions in this? Okay, what is MNIST database? I'll be showing that shortly. So can you understand the layers in neural network? Okay, please give a hand raise if you can understand. Okay, thank you. So this is the processing that will happen in each single node of the hidden layer and the output layer. The same processing, nothing different. The output layer, the activation function alone will be different based on what application you are using. If you're going to classify the data, input data, we will use some activation function called softmax. If you are using to predict a continuous value in the output, we'll be using something called as linear activation. So it depends on what purpose you are building the neural network, the activation function will differ. Here, another two things that are happening. One is forward propagation, where your data will be propagated across all the neurons. Just observe this. If this is, we are providing two input data here, that is sent to all the neurons. It will affect all the neurons equally, right? So the data is propagated from the front to the end. So this is forward propagation. And at the end, so we will get an output. We already have a desired output in our labels. I told you, right? Supervised learning, we will have the inputs as well as the actual labels. So at the output, we will measure the difference between the predicted output and the actual label we are having. And this error will be propagated backwards. So it will be propagated to all the nodes. So these nodes, based on that error, will adjust the weights accordingly. So it will try to adjust the weight to get a better learning. If the error is more, so the nodes will try to adjust the weights so that in the next iteration, the error will be reduced. So this will be happening for a number of iterations. All right. So this is a simple working principle of a neural network. And this artificial neural network is not suitable for images. So there are applications that have been developed for neural network, but the problem is we need to capture more information from the images and feed that information to the fully connected network. So for that purpose, we need some layers upfront. So this is where convolution neural networks comes into play. So if you see here, the last three layers, these last layers, they represent a fully connected network, what we have discussed now. All right. But before that, we pass the input image to a number of layers. We have a convolution layer. Why I'm putting multiple boxes? Because convolution layer is nothing but filtering layer. We apply filters. We can apply multiple filters to an image to learn multiple information from the image. That's why I'm putting multiple boxes. I'll show you how convolution layer works. Then we have a set of max pool layers. So each output will be passed through a max pool layer. This max pool layer will reduce the dimension of the convolution layer. So why we are reducing dimension? So that we can utilize the computational power properly. We have more dimensionality, so the computation speed and processing may be limited. But if you reduce the dimensionality, we can quickly compute. All right. So max pool does that. It reduces the computation, dimensionality, without much loss in the actual information. So we are passing through a set of convolution layer and max pool layer. And the final output of the max pool layer, we are flattening, which means all these things, all these outputs, we are converting it to a single vector. Okay. So each of these cells will have a value. It's a numerical value. Your input image is a numerical value. Everything happening here is numerical operations. And finally, you will get a set of numerical output. Okay. And that numerical values, you will send it to the layers. So I'm sure you're pretty confused now. So what does this convolution layer and max pool layer does? So I'll explain to you that, and then let me see if you can understand it. So here I have added a GIF file which I taken from a Medium website, from an article in the Medium website. So see, we are having a 3x3 mask. We call this as a filter or kernel. So we will apply this across images. So suppose if you are applying to the first 3x3, so we will multiply. So 7 into 1, 2 into 0, 3 into -1, 4 into 1. So we will perform element-wise multiplication and add everything together. That value, we will replace the middle pixel. So this is a 3x3 we are covering, right? So the middle pixel is 5. That we will replace by the answer. So if you see this GIF file, when it goes to the first one, let's see, the output is 6. So here it is getting replaced by 6. Then we'll move one step to the right side, take the next 3x3, do the same operation. Output will be -9. So we replace it -9. Then to the next step. Once we come to the end of column, then we will go to the next row. So likewise, in a zigzag manner, we will move the filter or the kernel across the image, and we will compute the output image. So if you are aware of image processing, if you had studied image processing, you would realize that this is a filtering operation. Okay, this applying this kernel, it's like a filtering operation where it gets to learn different features in the image. It can learn vertical lines, it can learn horizontal lines, it can learn curved lines, it can learn multiple patterns from the image. Okay. Then the max pool layer. Suppose if this is the output of the convolution layer. So you have to note one thing here in convolution layer. Initially we had a 5x5 image, but at the output we are having 3x3. Because when we take the first 3x3, we replace only the middle value. So the first row and first column will go away. So when we perform convolution, there is an option called padding. If you do padding, it will add a rows and column of zeros to the top and left and right. If not, it will reduce the dimensionality by 1. So 5 cross 5 will become 3 cross 3. Okay. And max pooling and average pooling, two types of poolings are available. So when we say max pooling, it will take, if I say the pool size is 2 cross 2, it will take every 2 cross 2 and takes a maximum value from there. So here it is 100. Here the maximum value is 184. Here all are 12, so it is 12. And here it is 45. Whereas average pooling, it will perform average of the 2 cross 2. Every 2 cross 2 matrix, it will take all the 4 numbers, compute the average and replace them. So this is how the convolution and pooling layer works. So what happens in pooling layer? The 4 cross 4 is reduced to a 2 cross 2. So the dimensionality is getting reduced. And then after the final max pooling layer, so everything will be converted to a single vector and it will be passed to a neural network. So can you understand this? Please, okay. Hand raises there. Okay. So what is sigmoid or hyperbolic? Sir, if you're asking about the sigmoid activation function, so we will probably use it for classification purposes, where it will create a threshold. Like if it is beyond a threshold, particular threshold, it will be classified as a one category, and below the threshold, it will be classified as an additional category. So you can refer that. The curve is available online. A simple search will give you the result. So it is a curve that helps with the classification. So when you're doing regression, we'll be dealing with straight lines. When we go for classification, we will convert the straight line to a curved structure. The sigmoid activation helps in that. All right. The handwritten digit recognition. This is where we are coming with MNIST. Someone have asked about MNIST. So MNIST, it is a database. It is a large database of handwritten digit images. So what they did is they made American high school students and the employees from American Census Bureau to write down numbers, and they captured that using camera. So this database has around 70,000 images, so 60,000 training images and 10,000 test images are there, right? And these images are pre-processed. So they are converted into black and white. They are black and white images, and they are restricted to a size of 28 cross 28, which means there will be 28 pixels along the rows and 28 pixels along the column. So this is the basic structure of handwritten digit recognition. Now we are going to use this database to recognize these digits from the images. So I have given some samples here, right? See, this is 5. You can see it's a 28 cross 28. We are using limited number of pixels. So automatically the image is kind of pixelated. It's kind of broken, right? But you can see the structure. So this is 5, this is 0, this is 4, this is 1. And also you can see that it is not like the printed text we have. We don't have any straight lines here. Even the 1 is curved, because these are captured from the digits written by actual people. Okay, so that's a challenge here, right? So we are having these kind of labeled images. We have the image as well as the corresponding label. So I have created a convolution neural network. I can show this code. Okay, so the MNIST data set can be imported from a package called Keras. So the Keras is a machine learning package that is part of TensorFlow that is available. So from that package, this is a Python code. I hope I'm not sure if everyone is aware of that. This is a Python code. We are importing libraries to support our code here. So we can import the data set directly from the Keras package. And here, while we are loading, we are loading it separately, train data and text data. Okay, and then we are reshaping. So whenever we are giving the images to a neural network, we will add another dimension to that. A one will be added. Why? So this is to tell the neural network whether we are having a single channel image or a multi-channel image. So what is multi-channel image? The color images that we are using now, right? The images that we capture with our phone. These are all multi-channel images. It will have three planes, R, G, and B, red, green, and blue. So each pixel will have three values, a combination of these colors, R, G, and B. These three are the basic colors. So different values for these colors will result in different colors in our image. Now we are dealing just with a black and white image, so there is only a single image here. And then we are normalizing the image. This is something we are not always do uh, to reduce the range of the images. Like when we divide by 255, so in a black and white image, the black pixels will be 0, white pixels will be 255. Okay, so it is called a grayscale image actually. When it is 255, the original image is a grayscale image. So it can have values from 0 to 255, where 0 is black and 255 is white. In between, we will have different shades of gray. So when we divide by 255, so automatically the image is converted into pixels with the zeros and ones. So every image processing will do that to reduce the range of the pixels. Then we convert the labels, the train Y and text Y, they are the labels. The labels are actually numbers now, right? So we are going to recognize digits. The digits will have 0 to 9. So the labels will have numbers 0 to 9. So for your model, we need to convert it as a categorical data. See, I'll come back to the slide. You can see here the output layer has 10 nodes. So these 10 nodes denote the 10 numbers 0 to 9. So what will happen if the node 1, the first node produces higher value compared to the other nodes, then we can say that it is digit 0. Okay, first node will correspond to digit 0, second node will correspond to digit 1, likewise. So this is the conversion that we are doing via categorical data. So we are converting the integer data into a 10-bit value, categorical data. Can you understand? Please give a hand raise if you can understand. So we'll convert to 10-bit data. For 0, the first bit will be 1. For 1, the second bit will be 1, all the other will be 0. For 2, the third one will be 1, all the others will be 0, likewise. Can you understand by what I mean by categorical data? Can you please raise your hands? All right. So by performing this categorical, we are converting the single digit into 10 bits so that we can provide 10 output layers in the model. And again, I am defining the model. See, it's very simple. It's a sequential model. Sequential in the sense one layer will give the output to the next layer. Okay. So and we have to add the sequence of layers. So first a convolution layer. I'm using 32 different filters. The kernel size is 3 cross 3, just like the example I showed you, GIF file. And the input image is 28 cross 28 cross 1, the original input image. And then next you add a max pooling layer with a 2 cross 2 kernel size. Then we include the flattened layer and followed by a hidden layer with 100 nodes, and then an output layer with 10 nodes. Okay. So that is what we have given here: a convolution layer, a max pooling layer, flatten, then a hidden layer, and then the output layer. You can see that the convolution layer, the original input image size is 28 cross 28, but it will convert to 26 cross 26. Because as I've shown you in the GIF file, when we perform convolution, the top and bottom row, the left and right columns will disappear. Okay. And then when we apply max pool layer, it will be halved. We have seen, right? The 4 cross 4, if we take a kernel size of 2 cross 2, that will be converted to a single digit. So 4 cross 4 structure will be converted to 2 cross 2. It will be halved. So I'll show you. The 4 cross 4 will be converted to 2 cross 2. So 26 is converted to 13, 13. And then when we flatten, all these will be converted into a single layer. So 32 into 13 into 13. totally we'll be having 5408 values. It will be converted to a single layer, and this will be connected to the dense layer. So each of these values will be connected to all the 100 nodes in the dense layer. Okay, and then the output will have 10 layers. And these are some of the parameters we are giving, the training parameters. So the optimizer, there are a number of optimizers. Adam is one optimizer that is commonly used across multiple applications. And for entropy, now this we are designing as a classification system. Given an image, the system has to say which class it belongs to, whether it is 0 or 1 or 2. So for classification, the commonly used loss is categorical cross entropy, and we give a batch size of 32. So if we don't give a batch size, what happens is, I told you that the neural network runs for multiple iterations. During each iteration, it will take all the images in one go. Like for example, in training, we have 60,000 images. It will take all the 60,000 images and try to train. At that time, we will face memory issues. So to avoid that, we are giving a batch size of 32. So it will process 32 images at a time instead of providing all at once. And epochs is the number of iterations. We are going to train for 10 iterations. Validation split is 0.2. So we are already having a training and test data. The training data, what happens is we will split 20% of it. 0.2 means 20% into validation. So it will train on this 60%, and it will use the remaining 20% to validate how the model has trained. Okay, so if you look at the code, so when I am fitting the model to the training data, I will give both the input as well as the labels as well. And I'll give the batch size, epochs, validation split, everything. Okay, so model will train, and I'll get the training performance like this. This will take some time. I will run it. Perhaps I can show you later on. But I have the results. Sorry, I'm facing some issue here. Okay, let me see. Okay, I'm having some issues, so let us not bother. So I trained the model here, the training performance. You can see that it goes up to 100. So this is like starts from 95. Even in the 0th iteration, it starts from almost 95%. Slowly the performance improves, goes almost to 98 or 99% here. And if you parallelly consider the loss during each epoch, okay, the loss initially will be high. What is loss? The difference between the actual output and the predicted output. So that loss will be initially high, but with each iteration, that loss is getting reduced. It's almost down to 0. Okay, so this is a desired performance. So your loss has to increase, your accuracy has to increase with each performance, and loss has to decrease. So someone asked about accuracy. So what is accuracy? Out of the given images, how many images or how much percentage of images are detected correctly? That is the accuracy. Okay, so we are getting close to 98 at the end of the model. So around 98% of images are getting accurately predicted. And then we calculate the test accuracy. So if you see the code here I am training the model, and then here what I do is I evaluate the model with the test data set. Okay, so even though we are providing the labels to this function, it will not use the label. In learning, it will use the label to learn. But here, this label is just to evaluate. It will try to predict from the text data without looking at the labels and then compare with the actual label. So the test accuracy, we get around 99%, 98.7 approximately. So we just use a simple architecture with one convolution, one max pool layer, and one hidden layer. And with that, we are able to get a 98.7% accuracy. Are you able to follow me? Please give a hand raise. Are you able to follow this training pattern? Okay,
Yes,
what
sir.
is the relationship? Thank you. what is the relationship between biological neural network and artificial neural network? Sir, I am not aware of the biological neural network because I have not learned about how our neurons function. Basically, but what a biological neuron does it, each neuron will process information and spread the information across other neurons. So since our nodes in the neural network does the same process, we are calling it as artificial neural network. We are treating the nodes, we are considering the nodes like the neurons of a brain. Okay. All right. So this is a simple system that we implemented only for detecting digits, individual digits, a 0 or 1 or 2, like that, individual digits. Then there are alphabets. So if you want to train on individual alphabets, there is a data set called EMNIST, extended MNIST, that consists of uppercase and lowercase alphabets as well, in addition to the digits. You can try that. So these are all very basic. What is the purpose of OCR? We need to recognize the entire text. Okay. So for that, some advanced libraries are available. I'll discuss two libraries here. So I wanted to show a demo, but unfortunately, there is some dependency issues. I'm getting an error. So nevertheless, I will show the output as for you. So this ECOCR comes with pre-trained models, the models that are already being trained on a number of languages and scripts. It utilizes CNN and other advanced, there are some advanced CNN architectures with additional capabilities like recurrent neural networks. There are something called LSTMs. There are more advanced networks now. Even CNN is considered basic. So we are uses CNN and RNN. You can explore more on that. And it provides a single interface. So we don't have to do text detection and recognition seamlessly, separately. So it provides a single interface which performs both in a sequence. And it is open source. That is a prime thing. So you don't have to pay for it. You can install the Python library and you can work on it. So again, I will show you the code. I'm not able to implement it at the moment, but I will show you the code. It's very simple. So we are importing the ECOCR package. The CV2 package is computer vision package to read the image. So we are reading the image and we are creating a reader object of the ECOCR for the English language. So this is the object that will detect and recognize the images. Then into that object, we are giving our input. Input is stored in a variable called image. So we are giving an input into that and we will get the results. What will be there in the results? Bounding box and text. So for each text in the image, it will create a box around the text and the corresponding text value will be there. So this bounding box. So when I say box, okay, you can imagine, right? If it's a rectangular box, it will have 4 corners. So that's what we are getting here, the 4 corners of the box. And then we will have the, we'll plot the image, we will create the rectangle on the image using these values. And then we will put the actual text, the text that we are detecting on top of the image to show our results. I hope you can understand. The reader results will have boxes and the text. So we are drawing the box over the image and displaying the text on top of that. So, sorry. So this will be the result. I am sure viewing this will be a little difficult. So this is a top view of a Raspberry Pi model. So wherever the text is there, it is creating a box around that and displaying the text. So I will explain. Here we are having something called the B plus model, but the plus is not detected correctly. It is showing something called like -T. Similarly, here we have the number BCM2837, but here if you look at this closely, or consider this number TA2308, if you look at it closely, the A is not detected. It is like T14, something like that. So there are mistakes. What I'm trying to say is that it is not able to completely recognize the actual text, ECOCR, okay? But it is able to recognize most of it. Another library is a Keras OCR library that uses a different version of a CNN called Craft, and again it uses RNN. And again, this similar to ECOCR, it is open source, comes with pre-trained models that you can readily import and apply. So again, the code for that. So we are reading the Keras library, we are creating a pipeline using the Keras library, and then we are passing the image to the pipeline. We are using the function recognize function. Then we can, what is Keras as an advantage, an additional advantage that Keras has is that we can draw annotations using the Keras tool. That is, it will automatically create. We do, like in the last example in ECOCR, if you see that we have created rectangle and we have put the text on top of rectangle. Here we don't need to do that. We can use the tool draw annotations, pass the image as well as our predictions. It will automatically do that for us. So this is the output. So see that each individual. So in the previous case, this entire thing was captured under single box, but now each individual word is separately captured. But again, if you see, the B plus is represented as bit. And this number, BCM2837, but it is represented as something else. So there are issues here. Raspberry is represented as Raspberry. There are errors. It's not perfect. Okay. But it is still a good one. It's still an advanced one. Okay. Now coming to the final thing, the cloud solutions like Google is offering Google Cloud, Microsoft is offering Azure. So these cloud providers, they have developed their own algorithms, pre-trained models that have been trained on huge data sets that are available via APIs. Okay, so we can directly use that to get our text detection. So when we use this API, what happens is that, so we are passing our image to the cloud where it is getting processed and the output is being sent to us. So just give me 5 minutes, I'll explain this quickly. So to get this, actually, you need a billing account. You need an account in the Google Cloud. Once you create an account, you need a billing account. You have to add like a card or a UPI or whatever they provide. So you have to add something to create a billing account. Okay, and then you need to create a project. So this is the home page of the Google Cloud Console. Here, if you go to select project, so I have already selected a project. If not, you can create a new project. So I will go to my selected project. Then here I will go to API and services, where I'll click enable API, or I'll go to libraries. Better, I'll go to library. So this will consist of list of APIs that the Google provides. Here I will search for Vision API, and we will have something called Cloud Vision API. Click that. I have already enabled, so it is showing manage here. Otherwise, it will have enable. So you can enable that. Okay. So once you enable that, you can go into that API. You can manage. There you will have something called credentials. So please remember, to every API that is available on internet, if you want to make an API call, you need credentials for that. So here you can click create credentials, and then you can click service account, and you can create an account here. Okay, but I have already created an account, so I am not going into that. I'll click that account. Here I can go to keys, and I can click add key to create a new key, or I can use an existing key here. So I have already downloaded the existing key as a JSON here, and I have imported that JSON file in the code. So I'll open the code. So see here, we have to download some of the libraries, the OAuth library as well as the Vision library from Google. Once you do that, you can get the credentials from the JSON file, right? And then we can, from the Vision package, we can call the image annotator client, and we can access it using the credentials. Then we can open the file, convert it into a bytes. So when you are transmitting your image to the Google Cloud, you have to send it as a bytes. And then you can use the image function to send the image to the to your Google Cloud. And then you can get back the response using client function that will detect the text and send it to us, and we can display the text. So I'm giving the same image, the Pi board, the board that I showed you now, Raspberry Pi board. So let us run this. See how quick it has come. So we are having the GPI J8 Raspberry Pi 3 model. Again, the B plus is displayed as BT, but otherwise the Raspberry Pi word is detected clearly. And these numbers, there is no issues with these words and numbers. Everything is created, detected perfectly compared to the libraries that we use. Okay, so the cloud APIs give a far better performance compared to the libraries that we are using. But still, the libraries we can utilize for when you have a clearer document. Like for example, if I want to direct the text in this PPT, I can use that. It might provide better results. Okay. So finally, before concluding, I want to show a couple of videos. In Samsung mobiles, the latest mobiles, I'm not sure if it is available in every mobile or high-end mobiles. So in the camera app itself, we have a OCR here. So I will run this. You can see here, this is the text button. On an image, I click the text scan button. Then it will automatically give the text value. I can copy that and paste it somewhere. See, within seconds, this is called real-time inference. Okay, within seconds, the text is getting detected. As soon as I click the text scan button, within seconds it is getting detected. I can copy that and paste it anywhere. Similarly, I think most of you would have used Google Lens app. Google Lens have even more advanced. You can translate in real time. So observe carefully. Here we have a translate function below. You can see that. So first I'll click the translate function in this video. And then I will detect the text. So it's in output is in English. I'll change it to Tamil. You can download other languages also. Okay. Then I point it to a text. So this is a Google search result for OCR. And then I click the translate button. See what happens. Instantly, everything is getting translated to Tamil. So these are some crazy real-time inferences using OCR. So within an instant, you can get the text like that. So that is why the advanced systems can provide more, can be used in more applications that require immediate results. Okay, so that's it from my end. If you have any questions, you can ask me. So I hope I've given a complete picture. So I started with the traditional model, what we did there, and then how we moved on to neural networks and convolutional neural networks. And we did a basic example, digital recognition, and we tried to implement the Python libraries that we are having. Unfortunately, I was not able to run that in real time, but the Google Vision, I was able to do it in real time. So similar to Google Vision, there is also the Azure Vision created by Microsoft. You can try that also. Only some procedures will be varying, but other than that, that would be an easier one too. So any questions from anyone? Is there any free OCR software or online tool? Yes, sir. The libraries I showed you now, the ECOCR and Keras OCR, they are free to use Python libraries. And I think the ECOCR has an online page as well, where you can upload the image and get the text. And the Google Vision and Microsoft Vision, if you can opt for a free subscription and try it out. I think when you offer a free subscription in the Google or Microsoft Cloud, they provide you with an initial amount, like a $2,000 credit. So until that credit is over, you can try out different systems in that. Any questions? So I will share my mail ID. You can contact me in my mail ID if you need any further clarification.
Participants, if you have any questions, you can ask now.
You can search online. There are a number of OCR tools available. So I just gave you samples. You can explore more. Any other questions, please?
It seems no questions from the audience. All are very clever in the topics. So, as the fourth day draws to a close, we would like to extend our sincere gratitude to the valued resource person for offering priceless ideas on organizing the technical content, the eminent faculties and researchers for their insightful contributions, and the organizing team for their tireless work. We are grateful that you are all a part of the quest for academic achievement and exploration. Let's go into this coming week with a fresh sense of purpose and a shared dedication to education and development. So tomorrow's session will be from 12:30 to 1:30 p.m. Thank you all.
Thank you, everyone, for this session.
Anand sir, thank you, sir.
Thank you, sir. Thank you so much.
Thank you. Thank you. Thank you.